Good morning. Well, I see it's time to begin. Today, we're going to start on the second half of section 2.8. It's called composition and decomposition. Okay, the notation, and I see I need to pull this down a little bit. Here's your notation for that. Now, what this business means is we're going to take this value and substitute it into that equation. We're going to take this equation and substitute it into that one. Here's another way of writing. We're going to replace the x's in the f equation, if you have two different equations, with the entire g of x equation. Now, just for a little bit of review, let me turn the lights off so it won't be quite so hard to read the screen. Okay, that should be a little easier for you to see at this point. Okay, we had this problem before. If f of x is x squared and g of x is x minus 3, then actually, I've got a slide out for. Here's the slide I wanted. Okay. Okay, if we had this is showing that we are replacing the x in this equation with m minus 6. Okay, when we do that, then we distribute 3 times the m minus 6 plus 1, which then in turn gives us 3m minus 18, and then the plus 1. Basically, what we've been doing when we've been showing this notation is we have been substituting this into the x's of that equation. Well, composition is fundamentally the same thing. If here's the f of x equation, if we're going to say f compose g, then that means we're going to take the g equation, x minus 6 in this case, and we are going to substitute it into the f of x equation. So 3, the substituted value, that's real good, plus 1, distribute, and we get ultimately the 3x minus 17, just like we did up here. Now, that's all that composition really is. A lot of people get confused about the difference in composition and adding and subtracting, just doing the operations on functions. But composition is basically a substituting of one into the other. Now, the order matters on composition. F compose G means we're going to substitute the G value into the F equation. If it had G compose F, then we would take the F equation and substitute it into the G equation. So order matters on those. Okay, now let's go back to here. Okay, I have 2 equations. I have f of x is x squared. I have g of x is x minus 3. Okay. And I tell you to find f compose g substitution of 3. Now, this is a little bit different than when you just have the equations. You can go ahead and work the equations and then substitute 3 at the end. But generally, it's better, more convenient for you if you will take the 3 substitution for g, get an answer, and then take that answer into f. Okay? So we substitute 3 into the g of x equation. And if we substitute 3 here, we get 0. That's an equal sign, not a less than or equal. Okay, so f of g then, okay, so g of 3 ultimately equals 0. Now then, we're going to take that 0 and put it into the f equation. So in this case, we get 0 anyway because 0 squared is still 0. Okay, let's go over these examples. F compose g of 5. Okay, we got g over there, we've got f of x over here. So we're going to take the g of x equation and we're going to find the value if we substitute 5 into it. So that gives us x minus 3, and we substitute the 5, and we get 2 for g of 5. So g of 5 equals 2. All right. Now, let's take this 2 and substitute it into the x equation. So f of g of 5, we're substituting this into that, equals 2 squared, which the answer then is 4. So f compose g of 5 equals 4. So what are we doing? We are taking this number, substituting it into this one, getting an answer, then taking that answer and substituting it into this one. Okay, let's go to this problem. This is just another way of writing f compose g of 0. This and that mean the same thing. They're just telling you, okay, we got to find g of 0. So g of 0 would be 0 minus 3, which is equal to -3. So now we do f of g of 0, which is f of -3. Okay. And then that gives us x squared, okay, which is equal to 9. Problem D. Okay, we're going to contrast problem D with problem E. I've got problem E right here. And I've got D right here. Now, notice the only difference in D and E is we're changing the order of G and F. So in this case, G composed F of 5 becomes G of F of 5. In other words, we're going to replace 5 into F, and then we're going to replace that answer into G. Okay, it becomes that. So let's start dealing with numbers. Okay, so F of 5 is going to be 5 squared, which is 25. So G of 25 then is equal to 25 minus 3, which is equal to 22. So G of F of 5 is 22 compared to F of G of 5 is 4. And I do this to demonstrate that the order does make a difference. We'll go ahead and do numbers, problem F, which is F of G of 0, which is the same thing as F composed G of 0. Okay, these two are interchangeable. Now, let's start working this problem. First, let's find G of 0. G of 0 would be 0 minus 3 equals -3. So we take the -3 and we substitute it in, and we get for F of -3, we get -3 squared, which is 9. Now, you might ask, why are these two the same? Because they're the same problem, just written a different way. I guess I better erase this stuff before I go to the next slide. Okay, I've already used this slide to show you what it really is. Okay, so now, this is a parabola. It's going to open upwards because that's positive. Okay, this is a line. So we're going to compose a line and a parabola. Now, let's see, what requirements are they going to put on us? They're going to put us compose G into F. And we're just going to leave it in equation form. So we're going to compose G into F. That means we're going to substitute 5x plus 4 here and here. Okay, so basically this is we're taking the g of x equation and we're substituting it into f. Or in other words, this could be written that way. Now we're actually going to do it. Okay, x squared, 5x plus 4 quantity squared, minus 3x plus 1. We've got to FOIL this. Gives us 25x squared plus 40x plus 16. We've got to distribute this negative 3. Gives us negative 15x minus 12. And then we bring down the 1. Now we combine like terms. And it simplifies to this. Okay? Now, what are we going to do with this? Well, actually, we're done. That's your answer. In other words, when we took that parabola and we substituted this line value in for that, it created this very much steeper and higher parabola, or quadratic. Okay, here's another one similar. Same original equation. This time, we're going to do it the other way. We're going to substitute the parabola or the quadratic equation into the line equation. Okay, back here before, we took the line and substituted it into the quadratic. Now we're going to take the quadratic and put it into the line. Okay, more notation, f of x. That shows that we're going to substitute this whole thing into that x up there. Or this and this is just laying it out with the x squared minus 3x plus 1. Okay, now we actually do that. G of x has the 5 times the f of x value plus 4. Distribute that 5, combine like terms, and this is the equation you got. You end up with a quadratic. If you compare the original one and this one, that 5 is going to make this thing's the sides steeper, okay, or vertically stretched. You want to use that terminology. And this 9 is going to raise up the height from 0, 0, or excuse me, from 0, 1 for the y-intercept to 0, 9 for the y-intercept. So it's shifting it up and making it steeper is what this composition resulted in. Okay, here's another one. F of x is 5x squared minus 1. G of x is square root of 5x plus 5. They want us to take g and substitute it into x. And here's the notation for that. So the 5 of x and the x squared with this substituted minus 1. Okay, this squared is 5x plus 5. Now we need to distribute this 25x plus 25 minus 1. With a final simplification, we've got this line. Okay, when we substituted a radical, a square root, into a square, it knocked this thing down to a 1-degree equation instead of a 2nd-degree equation. Knocked this one to a 1st degree instead of 2nd-degree equation. Okay, now we're going to do just the opposite. We're going to take this square root and we're going to substitute in the 5x squared minus 1. Okay, so here's my g of x equation, the 5, and then I substitute the f equation where x was, plus 5, all under the radical. I simplify this, I distribute this 5 here, and there's the 5 brought down. Okay, these two cancel each other out, minus 5 plus 5. So I get this 25x squared is a perfect square. 25 is 5 squared, x squared is x. So we extract those, but we have to use absolute value of x if you recall, okay? Or the plus or minus in this case. But the preferred, this is going to force us into plus or minus anyway, okay? But you can see the difference. The order does make a difference. Okay, now we've got a rational problem. Anytime we've got a fraction with variables in it, we have something we have to worry about. A domain check. X cannot be positive 4 because then we get a 0 denominator. And at some point, we need to make that statement. Now, in this case, they want us to find the f equation composed with g with a value of 9 for the g equation. Okay? So, g of 9 would be 2 times 9 minus 8. 2 times 9 is 18, minus 8 is 10. So g of 9 is 10. Now we take that 10 and substitute it into the x equation. So we have 3 over 10 minus 4, which gives us 3 over 6, which is 1/2. Now, like I said, right from the beginning, we should have written the statement x not equal to 4. Okay, now we're going to do it the other way. We're going to take f of 6 and compose it into g. Notice we always go right to left on these. So we take the 6 and we substitute it into the f equation here, and we get 3/2. Now we're going to take this 3/2 and we're going to substitute it into the g equation. So 2 times x minus 8 gives us 6 over 2 is 3, minus 8 is -5. Okay? Once again, the order matters. We got to do a domain check up here also. X can't be any number bigger than 8. And I said that backwards. X can't be anything bigger than 8. Why? If this is a 9, then you get a negative square root, an imaginary value. So we have to put this disclaimer in here that x has got to be, can't be bigger than 8. Now we can go ahead and work this problem. Whoops. I gotta work this problem. Okay, we can do that. So let's try the first one. F of G of -4, which is going to give us, okay, we take the G and put in -4, 8 minus -4, which is equal to square root of 8 plus 4, which is equal to square root of 12, which is equal to 4 times 3. That'll extract, which is 2 square root of 3. Okay. Now, we've got to take that 2 square root of 3 and put it into F. Squared minus 3 times 2 square root of 3 plus 1. This is going to give me 4 times 3 minus 6 radical 3 plus 1, which is 12 minus 6 radical 3 plus 1, which is 13 minus 6 radical 3. Okay. Now let's go to one of the others. Okay, let's go to item B. G of F of -5. You know, if it helps you keep track of stuff, you could use brackets there instead of a double parentheses, but that's up to you. Okay, so we're going to take the F equation and we're going to replace -5. So -5 squared minus 3 times -5 plus 1, which is equal to -25, or excuse me, positive 25 plus 15 plus 1, which is, that's 41. So now we take G of 41, which is equal to square root of 8 minus 41, which is square root of negative 33, which is, or simply undefined. Okay. That's why we have to do this domain check, to make sure that our answers are actually usable. Okay, now let's do F compose G of 9. this could be rewritten as f of g of 9 like I said, I don't know if that makes any more sense to you or not. It doesn't matter. So we're going to take the g and we're going to put a 9 in there. G of 9 is going to be equal to radical of 8 minus 9 equals square root of -1, which is I, undefined. Okay. Let's try g of f of 10, which would be g of f of 10 this way. So we're going to take the f equation and replace the x's with 10s. Okay, this is 100 minus 30 plus 1, which is equal to 69. So now we take the g equation, square root of 8 minus 69 is equal to square root of -61, undefined. Okay. That again, when we have radicals and when we have variables in the denominator of a fraction, we've got to do that domain check to see what answers are not usable. Okay, we got to do our domain check. X cannot be 2. Okay, so let's write that down. X not equal to 2. Excuse me, -2. So let's substitute in some values. We're going to take the g equation and we're going to replace the g in this case. Well, we're just going to substitute the equation. So here's the f equation, the 3, the x replaced with g, and the plus 2. It simplifies. -2 plus 2 gives you 0 there. So this simplifies to 3 over 3x. The 3's cancel, and you get the equation 1 over x. Okay, as long as x is not -2, this thing will work. Also, in this case, x is not 0. So there's 2 different values that this one cannot be. What that means for us domain-wise, if we were asked to write the domain, then it would be everything, that pen doesn't write well. It would be everything from -infinity to -2, not including -2, union with everything from -2 to 0, not including 0, union with everything from 0 to positive infinity. Would be the set of possible x values that you could have on this problem that you could substitute in and get a real answer. Now, that doesn't mean it isn't going to be a goofy answer, but at least it would be a real, not imaginary answer. Because this is saying if you substitute in -2, you'll get an imaginary. And if you substitute or an undefined, and if you substitute in 0, you also will get undefined. Okay, they've put those disclaimers in there finally. I need to move those up to the very beginning though. And there's what I just told you. Okay, in this case, we've got a radical. Okay. Do I have a domain value I can't use? 3x minus 7 equals 0 plus 7. 3x equals 7, x equals 7/3. That is a value that we cannot have. That's a disclaimer. X is not 7/3. Now, let's go ahead and work this problem. Okay. Remember, x can't be 7/3. So here's my g of x equation. Here is my f of x equation. It doesn't say that up there. But here we're going to take f composed g of x. So we're going to take the f equation and we're going to replace this x. Oh, this is decomposition. I need to start all over. Decomposition. In this case, that h of x is the answer you get after you do this. Now, what they're wanting you to do is to find two possible equations, an f of x equation and a g of x equation, that could make that true. If that's the answer you get when you're done. Okay? Now, they're suggesting that these two equations would work. Let's see. If f composed 3 of x equals that, let's see if putting these two in would give me that. Okay. F composed g. So I take square root of x and I replace that with 3x minus 7. Well, that's simple. If I let this be the g of x to substitute in, and I put the square root over this one, so this goes under the radical, then that's what I get. And all of these, you want to go for the easy solution. There could be more difficult solutions, but they're wanting to go for the easy one. Okay, this is telling us that the composed answer is that, x plus 1 cubed. Well, what would we have for our f's and our g's? Well, x plus 1 can be the g, the one that goes in, and x cubed, or x cubed, which we replace this into would be the G. So in other words, this decomposition thing, yes, there are other more difficult answers that you could come up with, but work smarter, not harder for Carter. Okay. Okay, now, here we're contrasting adding, subtracting, multiplying, and dividing equations with doing compositions. Okay. If we do f minus g of 3, okay, we take the f equation at a value of 3's, the g equation at a value of 3's, and I didn't show you the original f and g equation, so you get 4 minus 3 equals 1. Okay. I'm guessing that f of x is equal to x plus 1, and g of x is equal to just simply x, negative x. Nope, positive x. I had it right the first time. Okay. Now, would that be true here? If I replace this with 3, I would get 4. If I replace this with 3, I would get negative 3 with an answer of 1. Okay. Now, problem B. G over f, that means we're going to take the g equation, x plus 1, and divide it by the f equation with a substitution of negative 2. So we take g, negative 2, and we take this, which would be negative 2 plus 1, would be 2. Well, apparently that isn't the right equation on this. Anyway, you get negative 2 in there. Okay, now compose. Okay, you substitute 1 into the f equation, and it says you get 20, you get 2. And then you substitute that 2 into the g equation, and you get 4. So these two equations are not correct for this after all. Giving you that answer. Compose here. I've got to go. I'm going to go back. Whoops. Oh, it says estimate the functions from the graph. Okay. That's where I went wrong. I tried to find the equations rather than doing what the problem said. Okay, so if this is the f equation, then f of 1 is going to be 2. Okay. And our way, and if this is the, we're substituting the 2 in here into the g equation. So 1, 2, and we get an answer of 4. Okay, Now we're going to do of -3. So we take g of -3, 1, 2, 3, which is -4. Then we're going to take -4 and find it on the F equation. 1, 2, 3, 4. Down here, which is down 2. And we get -2 for y. Okay, let's do F of itself. So we take the F equation and we find the value -3. 1, 2, 3. The answer is 0. The answer is y equals 0. Now we take, where is y equal 0 in this thing? And in this case, on the F equation. Well, that brings us to 3.1. So we're ready to stop at this point, and we'll see you tomorrow.